All right, welcome back to the deep dive. We're always going on about the cool stuff software can do, but today we're going to flip the script a bit and talk about how well it actually does those things.
Hmm, good point. It's kind of like you can have a car with all the bells and whistles, but if the engine sputters every time you hit the gas.
Exactly. It's not going to get you very far. And to really drive home why this matters, let's talk real-world impact.
Oh yeah, hit me with some numbers.
Well, remember that time Google went down for like, what is it, 5 minutes back in 2013?
Vaguely, yeah.
They estimated that little blip cost them over $500,000.
Oof, that's not pocket change.
Not at all. And more recently, there was that Amazon Web Services outage where companies were supposedly losing something like 1,100 bucks every second.
Yeah, that was a rough one. Makes you realize how much we rely on these systems running smoothly, huh?
Totally. So today, we're diving deep into the world of performance testing to understand how we can prevent those kinds of hiccups and keep things humming along. We've got a really insightful tutorial we've been digging into, and our mission is to give you, the listener, the core concepts without getting lost in the weeds.
Sort of like a performance test for your understanding of performance testing.
Uh-huh, I like that. So, first things first, what exactly is performance testing?
Well, at its heart, performance testing is all about making sure that software applications can actually handle the workload they're going to face out in the wild. It's like a stress test for your software. The big goal is to catch any of those performance bottlenecks, those areas where things start to slow down or break down.
Yeah, those pesky bottlenecks. You definitely want to find those before you release the software into the world, not after.
Exactly. You don't want your app to be the one causing those million-dollar outages.
Now, the tutorial we've been looking at talks about 6 main types of performance testing. Maybe we could break those down a bit.
Sure, let's start with load testing. So load testing is basically checking how your application performs when you have a bunch of users all doing their thing at the same time. The idea is to simulate realistic user traffic and see if any bottlenecks pop up.
So like seeing how your website handles a sudden surge of visitors during a big sale.
Exactly. You want to make sure the servers can handle the heat. Then you've got stress testing, which is kind of like load testing but on steroids.
Stress testing, so really cranking things up.
Yeah, instead of normal traffic, you're hammering the system with way more users or requests than it's ever likely to see in reality. You're basically trying to break it.
Okay, so finding the breaking point. Why would you want to do that?
Well, it helps you understand the limits of your system. Like, how much can it really handle before it starts to crack? It's better to find that out in a controlled environment than when you have real users pounding on your app.
I could see that. So load testing is about real-world usage. Stress testing is pushing it to the limit. What else do we have?
Okay, next up is endurance testing. This one's all about seeing how your app holds up over a long period of time. Think of it like a marathon, not a sprint.
Okay, so not just can it handle a burst of activity, but can it keep going strong for days, weeks, months even?
Exactly. You're looking for things like memory leaks that might not show up right away, but can gradually eat up resources and cause problems down the line.
Ah, those insidious slow burners. All right, what's next on our list?
Let's see, we've got spike testing. This one's all about sudden bursts of activity. Like imagine your website gets mentioned on a popular blog or something, and suddenly you have a massive influx of visitors.
So kind of like a flash mob for your servers.
Haha, exactly. Spike testing checks if your app can handle those sudden spikes without crashing or slowing down too much. Then we have volume testing. This one focuses on data, particularly in databases. It's about seeing how your app performs when it has to deal with huge amounts of data.
So like testing a system that handles millions of customer records or something.
Exactly. You want to make sure your database can keep up with the volume of information it needs to process.
Right, so that's volume testing. And last but not least, scalability testing.
Right. Scalability testing is all about seeing how well your application can adapt to changes in demand. Can it scale up to handle more users or more data as needed? And can it scale back down gracefully when things quiet down?
Hmm. Kind of like an accordion, expanding and contracting as necessary.
Exactly. This is super important for planning for growth and making sure your app can handle the future, whatever it may bring.
So we've got our 6 types of performance testing: load, stress, endurance, spike, volume, and scalability, each with its own focus and purpose. But what are some of the common problems that these tests are trying to uncover? Like, what are the red flags that tell you something's not right?
Well, the tutorial highlights a few key issues. Let's start with long load times. This is that initial delay when you first try to use an app or website, when you click a link and then you're just staring at a blank screen.
Yeah. That's like waiting in line forever just to get into a store.
Totally. And it's a major turnoff for users. Then there's poor response time, which is the delay between when you do something in an app, like click a button or submit a form, and when the app actually reacts.
So it's not just about the initial loading, but also how quickly the app responds to your actions.
Exactly. You want those interactions to be snappy. If there's a noticeable lag, it makes the app feel clunky and frustrating to use.
Yeah, it's like trying to have a conversation with someone it takes forever to answer.
Then there's poor scalability. This is when an app might work fine with a small number of users, but starts to crumble under pressure when the user base grows.
That's like a small bridge that suddenly has a ton of traffic on it.
Right. You need to make sure your app can handle the weight, so to speak. And lastly, there's bottlenecking. This is where you have specific points in the system, either in the code itself or in the hardware, that create a choke point and limit the overall performance.
Bottlenecks, so like a traffic jam on a highway.
Exactly. The tutorial mentions some common bottleneck areas like high CPU usage, memory being maxed out, network congestion, issues with the operating system, or even just slow hard drive speeds.
So these bottlenecks can really drag things down, even if the rest of the system is running smoothly.
Yeah, they're like the weak links in the chain.
Okay, so we know what performance testing is all about. We know the different types of tests, and we know what problems we're looking for. But how do you actually do performance testing? What's the process?
Well, the tutorial outlines a pretty clear 7-step process. So step 1 is to identify your testing environment. This means figuring out the exact hardware, software, and network setup that your application will be running on.
So knowing the lay of the land, so to speak.
Precisely. Step 2 is to identify your performance acceptance criteria. This is where you define the specific goals for how well your application needs to perform. Like, what are the acceptable response times? How much traffic should it be able to handle?
So setting the bar for success, right?
Exactly. Step 3 is to plan and design your performance tests. This is where you put on your user hat and think about how people will actually use your application and then design tests that mimic those real-world scenarios.
So you're kind of creating a dress rehearsal for your app.
Exactly. Step 4 is to configure the test environment. This means setting up all the necessary hardware, software, and tools you need to run your tests.
Getting the stage ready for the show.
Right. Step 5 is to implement your test design. This means actually creating the tests themselves, which might involve writing scripts that simulate user actions or configuring your testing tools to run specific scenarios.
Turning those plans into action.
Step 6 is to run the tests. Pretty straightforward. You set those tests in motion and see what happens.
Lights, camera, action.
And finally, step 7 is to analyze, tune, and retest. So you look at the results of your tests, identify any areas where performance didn't meet your criteria, make adjustments, and then run the tests again to see if those changes made a difference.
So it's an iterative process. You're constantly tweaking and improving.
Exactly. It's all about making your application as performant as possible.
Now, you mentioned analyzing the results. What are some of the specific things you're looking at during performance testing? Like, what are the metrics or data points you're tracking?
Well, there are a bunch of different metrics that can be useful. Some of the key ones include processor usage, which tells you how much of the CPU's power the application is using.
So how hard is the processor working, basically?
Right. Then there's memory use, which shows you how much of the system's RAM the application is consuming.
Making sure it's not a memory hog.
Exactly. Disk time tells you how busy the hard drive is reading and writing data. Bandwidth is the rate at which data is being transferred over the network.
So those are all pretty fundamental system resources.
Yeah.
What else are you keeping an eye on?
Well, we also look at things like private bytes, which
Right.
is the amount of memory that's allocated to a specific process that can't be shared with other processes.
Private bytes. So like the app's personal stash of memory.
Exactly. And committed memory, which is the total amount of virtual memory that's currently in use by the system.
Okay, so tracking how much memory the app is using overall.
Right. Then we look at things like memory pages per second, which tells you how often the system is having to swap data between RAM and the hard drive.
So the more page swapping, the slower things are going to
Yeah,
be.
exactly. We also look at CPU interrupts per second, which is how often the CPU is being interrupted to handle requests.
Interruptions. Those can't be good for performance.
Not usually. And then there's disk queue length, which is the average number of requests that are waiting in line to be processed by the hard drive.
Disk queuing. So how long is the line at the hard drive, basically?
Haha, pretty much. And then we have network output queue length, which is the same idea but for the network, and network bytes total per second, which tells you the overall rate of data transfer over the network.
So you're really getting a detailed look at how the entire system is performing.
Yeah, it's all about understanding where the bottlenecks might be and what's causing them.
Okay, so we've talked about system-level metrics. What about application-specific metrics?
Well, one of the most important ones is response time. This is how long it takes for the application to respond to a user's action.
So like how quickly a website loads or an app responds to a button click?
Exactly. You want to keep those response times as short as possible.
Yeah.
Then there's throughput, which measures how many transactions or requests the application can process per second.
Okay, so throughput is about capacity, how much the app can handle at once.
Right. If your app uses connection pooling to manage database connections, you'd also want to monitor things like the amount of connection pooling and the maximum active sessions.
Connection pooling, so making sure those database connections are being used efficiently.
Exactly. Then there are things like hit ratios, which tell you how often the system is serving up cached data, which is super fast, versus having to retrieve data from slower storage.
Caching is always a good thing.
Definitely. And then we have things like hits per second on the web server. For database performance, we might look at the rollback segment, database locks, and top weights, which can help you pinpoint bottlenecks in data retrieval.
Rollback segments, database locks, top weights. So getting deep into the database weeds there.
Yeah, sometimes you got to go deep. And then there are things like thread counts, which tell you how many threads are currently active in the application.
Threads. Those can be tricky to manage.
They can be. And garbage collection, which is how the application reclaims memory that's no longer in use.
Garbage collection. So cleaning up after itself, basically.
Exactly, keeping things tidy.
That is a lot of metrics to keep track of.
Yeah, performance testing can get pretty granular. But the key is to focus on the metrics that are most relevant to your specific application and your performance goals.
Right. So it's not about tracking everything, just the things that matter most.
Right.
Now, to make this a little more concrete, can you give us some examples of what a performance test case might actually look like?
Sure. So one common test case might be to verify the response time of a website under a specific user load. Like, you might want to make sure that the home page loads in under 4 seconds when 1,000 users are accessing it simultaneously.
Okay, so that's a pretty specific and measurable goal. What else?
Another test case might be to verify the response time of an application under load, but with realistic network latency.
Network latency, so simulating real-world network conditions where users might have different connection speed.
Exactly. You want to make sure your app performs well, even for users who might have slower connections.
Makes sense. What other kinds of test cases are there?
Well, you might want to test the maximum number of concurrent users an application can support before it crashes or becomes unstable.
Finding the breaking point again.
Right. Or you might want to check the execution time of a specific database query with a large number of records.
So making sure the database can handle those big queries efficiently.
Exactly. Another common test case is to monitor the CPU and memory usage of the application and database servers under peak load conditions.
So seeing how much those servers are being taxed when things get busy.
Right. And finally, you might want to test the application's response time under a range of load conditions, from low to normal to moderate to heavy.
Okay, so getting a comprehensive picture of how the app performs across different levels of usage.
Exactly.
Now, for someone listening who's interested in getting started with performance testing, are there any tools or resources you would recommend?
Yeah, there are definitely some popular tools out there. The tutorial mentions a few, like HP LoadRunner, which is a really powerful tool for simulating large numbers of users and analyzing application behavior under load.
HP LoadRunner. That sounds like a serious tool.
It is. It's used by a lot of big companies. It also specifically mentions LoadRunner as a virtual user generator. Another one that's popular is JMeter, which is an open source tool that's great for load testing web and application servers.
JMeter, so a more budget-friendly option.
Exactly. It's a great choice for individuals or smaller teams.
Great. So we've covered a lot of ground here. But before we wrap up, the tutorial makes a distinction between performance testing and something called performance engineering. Can you explain the difference?
Sure. So performance testing, as we've been talking about, is all about evaluating and reporting on the current performance of an application. It usually happens at specific points in the development process, like before release. Performance engineering, on the other hand, is more of a holistic approach. It's about building performance into the application from the very beginning.
So it's not just about testing after the fact, but about designing for performance from the ground up.
Exactly. It's about thinking about performance at every stage of the development lifecycle, from design and architecture to coding and deployment.
Hmm, that sounds like a much more proactive approach.
It is, and it can really pay off in the long run.
So to sum it all up for our listeners, performance testing is crucial for ensuring that the software we use every day is reliable, responsive, and can handle the demands we place on it. We've talked about the different types of tests, the key metrics to track, the process for conducting these tests, and even some of the tools that are out there.
And when you think about it, the consequences of poor software performance go way beyond just financial losses. It can damage a company's reputation, erode customer trust, and even impact employee productivity. So it's really worth considering what aspects of performance are most important to you in the apps and websites you use every day. Is it the speed, the responsiveness, the stability? It's something to think about.
It is. And with that, we'll wrap up this deep dive into the world of performance testing. Thanks for listening.
Thanks for having me.